We now determine secant theta given that tangent theta equals 6 over 5 and theta lies in quadrant 3. So first I'm going to rewrite this secant theta using the reciprocal identity, that is secant theta, and this equals 1 over cosine theta. So basically we have to determine the cosine theta using the given information. So I have constructed this right triangle in quadrant 3, and using this tangent theta, that is tangent theta equals opposite to opposite side to theta over adjacent side to theta. So this is given as 6 over 5, and this means opposite side to theta is 6. So I have marked this as negative 6, and adjacent side to theta is 5. So I have marked the adjacent side to theta as negative 5. Since the theta lies in quadrant 3, I have marked the opposite side as negative 6 instead of 6, because in quadrant 3 this y value is negative, and similarly the adjacent side to theta I have also marked that as negative 5. Since theta lies in quadrant 3, the x coordinate is basically negative. So that's why we have marked this as negative 6 and negative 5. Now the next step is to determine this hypotenuse ON, so that we can determine the cos theta ratio. And for that we can use the Pythagorean identity. So let me just remove this. Now using the Pythagorean identity, I can write down this OM quantity square. This is one of the side square plus another side square, that is ON side square. This equals the hypotenuse square. I'm sorry, this has to be MN. This is another side square, and sum of this has to be ON, that is the hypotenuse square. So this basically is the Pythagorean identity, that is sum of the squares of the two sides in a right triangle equals the square of the hypotenuse. So let's plug in the values of OM, MN, and ON. OM is negative 5, so this becomes negative 5 quantity square, plus Mn is negative 6, this is quantity square, and this equals On quantity square. So here we have negative 5 square is 25, plus negative 6 quantity square is 36, and this equals On quantity square. 25 plus 36 is 61. This equals On quantity square. So we now take square root on both sides, so that we can get ON on the right side. So on the left side we have square root of 61, and on the right side we have the square root as well as this power of 2 will get cancelled. So we have ON. So we get ON equals square root of 61. And so we can mark this on the right triangle. So let me mark ON as under the root of 61. Now we can determine cosine theta from this right triangle. Cosine theta basically is, according to Sokatova, it is adjacent side to theta over hypotenuse. So in this triangle OMN, the adjacent side to theta is OM, and then the hypotenuse is ON. And so this equals OM is negative 5, and then ON is the hypotenuse, which is under the root of 61. So we have determined this cosine theta, and this means we can find the secant theta just by taking the reciprocal of the cosine theta. So I write secant theta, and this equals 1 over cosine theta. Cosine theta is negative 5 over root 61. So it's basically we just have to multiply the 1 in the numerator by the reciprocal of the denominator, that is under the root of 61 divided by negative 5. So this can be written as 1 times of under the root of 61 by negative 5, we can simply write this as a negative of under the root of 61 over 5. So therefore, we have determined the secant theta equals negative root 61 over 5.